Hi, this is Mr. Manley. I'm going to look at a graphing for a couple of rational functions here. This first one I want to look at, I'm going to start the way I start with all of the functions that we've looked at so far this year with a table of values. And the first thing I want to look for is the y-intercept when x is 0. I can see that when I plug in x is 0, I'm going to get a 0 in the denominator. 0 in the denominator is undefined, so there is no y-intercept. Then I'm going to plug in a 0 for f of x. A 0 for f of x, you may be able to see where this is headed, but I'll just write it out here. F of x equals 0 is giving me the x-intercept, and that is going to mean really that x plus 1 is equal to 0 because the denominator will 0 out, right? Or I'll multiply both sides by the denominator and end up with x plus 1 equals 0. So x equals negative 1 is giving me an x-intercept at negative 1. Then for our steps for graphing a rational function, I'm next going to look for the vertical asymptote in the denominator. So I'll set the denominator equal to 0. And solve for x. Of course, solve by factoring here. Looks like I can get a negative 3 out. And then that'll leave an x, and then minus 3 equals 0. Let's just double check that. So that would be negative 3x squared and plus 9x. So factored correctly. And that's giving me vertical asymptotes at x equals 0 and x equals 3. Next, we'll look for the horizontal asymptote. Horizontal asymptote, based upon our rules for horizontal asymptotes, I've got y is equal to 0 for the horizontal asymptote. And this is going to be enough to get us started. So let's go ahead and get some graph paper up here. Get an xy axis here and here. And then get to the graphing. Negative 1, 0. I'm going to give myself a scale of 1. It's nice to always show your scale. Don't want to leave that up to any assumptions, although we do make those assumptions sometimes. It's best not to. So I've got negative 1, 0. Maybe I should do this in a different color. And I want to get a smaller pen here. Okay, so there's a negative 1, 0. I've got that. I've got the vertical asymptote at 0, so I think you can see that as I go over the y-axis, right, at x equals 0. And then I've got a vertical asymptote at x equals 3, which we'll lay down here, and the horizontal asymptote at y equals 0. Okay. Looking over to the right side here, let's start on the right side. I need to know what is happening over in this region, and I'm going to do that with a test point. So with the vertical asymptote at 3, the test point that would make sense would be 4. If I can't do this in my head and I need to do some work, the way to show what I'm doing is to use correct notation. So if you look at the bottom of the page there, I'm saying f of 4, and that's going to be 5 over, let's see, negative 3 times 16, so that's going to be negative 48 plus 36, and that'll give me a negative 5/12. Don't even need to be that specific, but that's nice to have that. 4, 1, 2, 3, 4, negative, so it's just below, I'm just below the x-axis, right? And that's all I need to know over here, right? So all I need to know is, am I above or below the x-axis? I see that I'm below the x-axis, and I'm just going to approach the asymptote from that point there, and then approach the asymptote to the right. And that gives us the right side of the graph. In the middle part of the graph here, I don't have anything going on yet either, so I'm going to find a point. So I'm going to plug in a 1 into my function. And again, I think I can do this pretty quickly without writing anything out. So if I plug in I get a 2 in the numerator, and then that's going to be negative 3 plus 9 in the denominator for a 6, correct? That would be -3 plus 9, and that'll give me 6. So I got 2 over 6, 1/3 in the numerator, and that gives me this point 1 for the x-axis, for the x-coordinate, and 1/3 for the y-coordinate. So I'll plot that point, and that's all I need to know. If I'm looking in this middle region here, I just need to know, am I above the asymptote or below? I'm above the asymptote, and then I'll just approach the vertical asymptotes from there. So I'm going to approach that vertical asymptote on the right and approach the vertical asymptote on the left. And that gives me the middle region. Okay, now I have this region over here to the left. So what's going on in this region? Now, one thing is I've got a point here, this point at -1, 0, and that frustrates some students, or it doesn't seem to be consistent with what you understand about asymptotes, that asymptotes cannot be crossed, but they can be crossed. An asymptote can be crossed. It's not that it can't be touched or crossed. It needs to be approached at some point, but it can be crossed as long as it's going to be approached. So actually this horizontal asymptote is already being approached over here. So it served its purpose. It can be there and be crossed. But we do need to figure out what else is going on here. If I look at, to determine this, I should really look at point -1, well, I could look at -2. All right, I'm going to erase a little bit of work here to give myself some space. And then in the table, I'll go -2. All right, now I want to know what's going on at -2. Again, I'm going to erase down here where I did f of 4 and put my f of -2 there. So there's f of -2, and that's equal to -2 plus 1 is -1 over, and I've got a -3 times 4 is -12, and then minus 18 when I plug in a -2 for the x's in the denominator. So what I've got here, if I look closely at this, if I just think about that, -1 over -12 minus 18, that's a negative over a negative, which is a positive. It's a really small positive number, very close to the axis. So I really do know what's going on here. So look, I know that to the left, this -2, which I'll put in my value there for my y-coordinate, I'll say -1 over -10, 20, 30. So I know to the left that this is above the x-axis, very close to the x-axis. I don't know how high it goes. I mean, it's definitely very close here. I don't know. It could come up and come back down. It could have already come up and it's very, but some way I want to indicate that it's above the x-axis, even if it doesn't seem completely to be consistent with the point that I found. Let me reconnect this. Okay, so I need to be above the x-axis over here and approaching the asymptote. So that's kind of difficult to draw, but anybody who is looking at this could look in my table here and go, oh, he's got -2 and -1 over -30 is positive. So in addition to looking at my picture, if they're uncertain about what's going on there, they could look and see that I'm above the x-axis. And then now I also know that I have this point here, and it's not a double root. So there's no way that it bounces off that point. It has to pass through. And since it has to pass through, I will pass through and approach the vertical asymptote. So that's a pretty interesting little function there. And notice the little details of, for instance, I think the two big details are finding this point here, finding this point to show that it's above the x-axis in case there's any ambiguity in my drawing and someone can't really tell what's happening in my drawing. That's one thing. And then the other thing is that I know what's going on. I know what's going on at that point. There has to be a y-intercept. I found that over here, -1, 0. Did I say y-intercept? X-intercept. There has to be an x-intercept at -1, 0. and there's no bounce, so it has to pass through. And that gives us that function. Okay, so let's move on to another one that I want to look at here. Okay, so this is going to be another rational function. This is a fun one. We see that it looks in this form. It's in a form that seems manageable if I just start going through the process. So if I just set up my table of values, and I say x, f of x, when x is 0, I can do that. I can plug in a 0, and I see that plugging in a 0, that zeroes out. And then I have -2 over -2 is 1, and 1 minus 1 is 0. So when I plug in an x, 0 for x, I get 0, 0, 0. So I've got that point. And then now I do have to think, now what if I plug in 0? Is there anything else going on? I can't really tell by looking at this whether or not something else is going on in this form, because I don't have the numerator. So let's go f of x is equal to 0, finding the x-intercept, and then that's going to be -2 over x minus 2 minus 1 is equal to 0, and then -2 over x minus 2 is equal to 1. Multiply through, I'm going to just keep the negative with the 2, and then I'll multiply by the x. So that'll be x minus 2 times 1 is x minus 2. Add 2 to the other side, and I get x equals 0. So that seems to be it. I got another 0, 0. I didn't get some other x-intercept out of that. So the x-intercept matches the y-intercept, and that's all there is as far as intercepts go. Okay, next we will look at the vertical asymptote. Okay, I don't have, I'm not in the form to do the vertical asymptote. I can't really say x minus 2 is 0, because I don't have this is not in the form some numerator of x over some denominator of x. I've got a numerator of x over a denominator of x minus 1. Now there's something that I could do with that, and I may comment on it down the line here. But for right now, I want to put this in the form, this rational function in the form that I have worked with, which is n of x over d of x. So I'm going to write this as -2, and then if I get a common denominator of x minus 2, I'll have minus x minus 2 over x minus 2. And then simplifying that, I've got a -2 minus a -2, which is 0, and then minus x over x minus 2. Now that's in my vertical asymptote, horizontal asymptote form that I'm used to working with. So that's really what I want to use. And now I can just look at this and say, oh, the vertical asymptote is x minus 2 equals 0. It is x equals 2. But without doing that, I would have just been lucky. If I just said x minus 2 equals 0 over here, and then x equals 2, I'm just getting lucky because I'm not using any rule or any method that I know works for every rational function of this form. So x equals 2 vertical asymptote, and then same thing with the horizontal asymptote here. This is not in the form. Now, if I just look at this piece, I would say yes, it has a horizontal asymptote at y equals 0. But I'm not using the correct form again. I'm not using the n over x d over x form. That's where my rules apply when it's in that form. So in that case, what I really need is, or what I would be really useful is being in this form, which I did. Now that's in the form where I can say that the horizontal, or the horizontal asymptote is y equals leading coefficient over leading coefficient, because these have matching degree. So I have a first degree over a first degree. So the horizontal asymptote is at y equals leading coefficient over leading coefficient. Now let's graph what we have so far. Here and here. And I've got 0, 0, vertical asymptote at 2. I haven't written my scale down yet. Horizontal asymptote at -1. There. And I'll just squeeze my scale in here, 1, 1. And then I have in this region over here, in that region, I'm looking, am I above or below the horizontal asymptote? Well, I am above it. I have a point there. So from there, I'm going to approach the asymptote here, and I'm going to approach the asymptote down here. And that's what I can do with that at this point. And then on the right side, I've got to find a point over here. And the point over here, I would need to let x equal 3. And when I let x equal 3, I think that comes out to -3/1. So that's going to come out to -3. So 3, -3. So I've got point 3, -3 there. And approach the asymptote. So I approach that asymptote, and the graph is complete. So the key to this really is that if you're in this form, the best way to do it is to get it into the n over x, d over x form. Now, you could say that I'm going to look at this function here. I'm going to figure out where that asymptote is, and then I'm going to drop it down by 1. Kind of, that could be appropriate. In this specific case, I would say it's pretty manageable, but we definitely want to say that. We definitely want to indicate that if that's what you're doing. And again, the best thing to do is to convert the function to this form. Okay? So happy graphing rational functions.